Even though this video is going to take a steaming pile of shit on the globe, I'm not going to enjoy it as much as most videos because it's also going to take a big steaming pile of shit on my buddy Roohif. Here he's trying to use the known angular size of the sun to do calculations with the sun on the horizon. I've told him before it doesn't work, and I know he's spent years and probably hour after hour with these Canigou observations and calculations, but I'm going to send this one out to feed the dogs once and for all.
And we can get a few clues here because we know that the angular size of the sun is about 0.53 degrees. So the distance between these 2 points is about 0.53 degrees.
Environs de Marseille. I probably can look that up. I don't know.
Yeah, the environment of Marseille. So somewhere around there. But that looks a little bit more than the one from the chapel. So that's probably 500 meters.
So 500 meters viewer height, and we know the sun is 0.54 degrees, and Canigou is around 270 kilometers away. Okay, I'm pretty sure this is the calculator that Roohif uses, but before we go over his numbers, let's look at some of the numbers he never points out. So let's check this out. Refracted horizon dip, 0.665 degrees. And also there's a couple other calculations on here he never covers. And we'll go over them later, and I'll show you why he doesn't cover them. Okay, so we know the sun is around 0.53, 0.54 degrees. And the approximate dip to a globe horizon is 0.67 degrees. So that bottom line is approximately 0.67 degrees. Let's see where that puts us. So that's got to give you one out of two things. Either that horizon straight in front of us in a flat earth horizon, which puts the globe horizon way down here, or it's already a globe earth horizon and a flat earth horizon would be way up here. So I had to literally raise and lower the screen to even fit the horizons on there using Roohif's math, using the sun to go by. So it's got to be one or the other. You got two choices. If that's a globe horizon we're looking at, then the flat earth horizon has to be up there off the screen, 0.67 degrees up. Now if it's a flat earth horizon we're looking at, then the globe earth horizon has to be down there below the screen. And I'm here to tell you, as I go back to the regular picture, that it's neither. That's globe fantasy calculations. But if we use all them numbers and apply them according to the angular size of the sun, that's what we get. I'm sorry, but my common sense tells me otherwise, Roohif.
So we know that this line, the true horizon in the photograph, is at a height of 1,677 meters. So
he just said we know in the picture the height to the horizon is 1,600 meters. How's that even possible? It's sea level. So in either model that could never work.
Righty. So Jeranism put out a video about a year ago about this Canigou mountain. So I thought I'd do a bit of photo analysis on it. The first thing we need to do is properly identify the peaks. And we can get a few clues here because we know that the angular size of the sun is about 0.53 degrees. So the distance between these 2 points is about 0.53 degrees. And we know the distance from Canigou to Aloche in France, where the photo was taken, is 263 kilometers. So let's plug the numbers into the Metabunk curve calculator and see what it thinks we should see if the Earth was a globe. So our distance to the mountain is 263 kilometers, and the viewer height of 320 meters gives a refracted hidden of 2,532 meters.
This time let's look at another number that he ignores, or never mentions anyway. This time we'll look at the horizon distance for his globe model. And as we've been doing, we'll give the globe the benefit and we'll use the globe refracted value. So the distance to the horizon is 68 point something. We'll call it 69 kilometers. So the globe dictates that the refracted horizon is 69 kilometers. So just remember that number. We'll let him say what he has to say here, and then we'll see how it checks out.
So let's go and plot all these levels on the original picture. And here it is. So the red line here is our expected horizon given standard refraction. These two white lines here are the two horizon markers that I've given. The lower one is the hard horizon and the higher one is the miraged horizon. This blue line down here is ground level at Mount Canigou. So you can see that this much of the mountain is obscured by water. It's almost like there's some sort of bulge there.
So before we check any of these distances, does that look like a bulge to anybody? It doesn't to me. Let's get back to the globe planes. According to the globe calculations, the distance to the horizon is 69 kilometers. That means that from the horizon to Canigou has to be over 200 kilometers. So 200 kilometers in that little space. So let's pull it up and see how far Canigou is from the sea altogether. So here it says that it's less than 50 kilometers. So less than 50 kilometers from the sea. Now let's look at this picture again and see what we got for distance. So according to Roohif, we know that this line here on the left to this line here on the right represents approximately 0.53 degrees, which according to his math is about 2.7 kilometers. Okay, but what we also know, we just looked up, from this line from Canigou to the ocean is less than 50 kilometers. But according to the horizon distance, there should be over 200 kilometers from the horizon to Canigou. So check it out. From there to there is 2.7 kilometers. 2.7 kilometers from one end to the other, and the 0.53 degrees. But from right here to right here is 200 kilometers. Well, and 50 kilometers. So that's 200 kilometers and 50 kilometers, depending on which information you go by. Any way you look at it, 2.7 miles covers almost the entire Zoom screen. So that little line can't cover 100 times more than the big line. But so I hope I got my point across, is that these pictures are three-dimensional. They're three-dimensional. You can't apply freaking the type of mathematics Roohif is doing. Maybe you could get some approximations if you're not trying to use a model or something like in real life. But for what he's trying to do, it's literally a joke. But once again, he's got it backwards. He's trying to claim a flat Earth horizon should be down there where it says sea level in blue. But how could a flat Earth horizon be down there? I mean, if we're being technical, that should be where the globe horizon is. About 69 kilometers to the blue line and about 200 kilometers to the Canigou. But that's pretty much what you get, is backwards thinking when trying to apply the globe model to reality. It's you get some crazy numbers like that. So Roohif, I think you owe Taboo Conspiracy and Jaren and a whole bunch of other people. I ain't gonna say an apology, but a retraction video at the very least. Well, at least after you run the numbers 1,000 more times and realize that you can't apply that type of two-dimensional globe model mathematics to three-dimensional reality. But for everybody who watched this all the way to the end, I appreciate it. If you enjoyed this video, please like and subscribe. Thank you.